okay? And I'm going to start with circles. And let's say we have an angle here that's 30 degrees. And let's say that our circle has a radius of 1. Can anybody tell me what the length of this arc is from here to here? 30 degrees? Okay. We're going to come back to that. 30 degrees is called the arc measure, right? The arc measure of an arc is defined as the measure of the central angle that creates it. Arc measure. But I'm asking for the actual length. How far is it from here to here around this curve? What about the circumference of this? Do you know the circumference of this? Right. Okay. Nice and easy. The circumference of this is equal to 2 pi. Does that give you a clue as to how long this arc might be? Okay, let me back up for a second. Right. You're looking for some portion of the circle. If I asked you how big was half the circle, you would divide this by 2. You would say it's pi. If I was saying 1/4 of the circle, you'd multiply this by 1/4. You'd say pi over 2. Well, the portion of this circle we're looking at is 30 degrees over 360 degrees, right? So whatever that portion is, if you multiply that by 2 pi, you'll get this distance. Yeah, right? We could divide top and bottom by 10. We can divide top and bottom by 3, so we get 1 here and 12 here. We can divide top and bottom by 2, so now this is pi over 6. Okay? So that's the exact answer. But you raised an interesting point. You used a calculator, right? Okay, let's talk about that. Has anybody ever told you what the definition of pi is? No, that's an approximation of pi. 3.14 is an approximation. But the actual definition, all circles are similar to each other. Right? You remember what similar means? Similar figures?
Same, like different sizes?
Right, same shape, different size. Okay? You guys did this in geometry with triangles, right? Same shape means that the corresponding angles were all congruent. But if it's a different size, it means that there's a proportion, there's a ratio, or a zoom factor, right? If the size of this is A and B and C, then this one here is A times some zoom factor, some ratio. And this is B times some ratio, and this is C times some ratio. And that's what it means to be similar for a triangle anyway. Okay? And in fact, when you learned how to do this, you actually learned shortcuts. Right? I don't have to get all 6 measures here to know that they're similar. I can say, hey, look, these 2 angles and these 2 angles, if you have 2 pairs of angles that were similar, then you knew the triangles were similar. If you had all 3 sides of one and all 3 sides of the other and you found out the ratio was all the same, you knew that they were similar. If you had 2 sides that had similar ratios and the angle between them was congruent, that was enough. There were 3 shortcuts. Does this sound familiar? Okay. So that was triangles. That was how you figured out that triangles were similar, which means they had the same shape, but they were a different size. With circles, it's way easier. Okay? Here's one circle. Here's another circle. They're already similar. How do I know? They're the same shape, but different sizes. There's not much to measure here. Okay? And that means that the ratios are all going to be the same. What ratios am I talking about? Well, the ratio across from here to here compared to the ratio all the way around. For every single circle you could ever draw, the ratio of the circumference to the diameter, right? This ratio right here is always going to be exactly the same number. It gets a little weirder because no matter what measurement system you use and no matter what size circle you pick, this is an irrational number. You can't get it exactly. Right? It's a decimal. It goes on forever. You can't measure that exactly. The circumference of a circle divided by the distance through the circle, irrational. And in fact, it was important enough of a number, right? It shows up all over the place. It was important enough of a number that they gave it a name. That's the definition of pi. That's what pi is. So then, right, if I multiply both sides by d, what happens? Oh, the circumference is equal to pi times the diameter. That's all it is. That's where it comes from. 3.14 is sort of an approximation. When you used your calculator, you got an approximation out to, I don't know, 5, 10, 15 decimal places. But the actual answer to the question, when this angle is 30 degrees and this radius is 1, this distance of an arc is going to be pi over 6. That means if all circles are similar, right? And this is 1, and this is 30 degrees, and this is pi over 6. What if I had a circle that was bigger, right? This is 3, and this is 30 degrees. What's this going to be? Okay. I took the radius and multiplied it by 3, right? Now I got to take the arc length and multiply it by 3. Well, that's pi over 6 times 3. That's not pi over 18. That's
3 pi over 6 or 1
pi over 2, right? So this right here is pi over 2. And you could do it the other way too. You could say, okay, look, this is, right, 6 across this way. So that means the whole thing is going to be 12 pi, and then multiply that by 30 degrees and divide it by 360 degrees. Basically, here's what's going to happen. Right? For 30 degrees, if you're talking about a unit circle which has a radius of 1, 30 degrees is going to generate an arc length of pi over 6. And then as you make the circle larger or smaller, right, if you multiply this by whatever size the radius is, that's what's going to happen to the arc length. Right? The radius is 1. This is pi over 6. If the radius is 2, this is going to be pi over 3. If the radius is, I don't know, 60, this is going to be 10 pi. Okay. Or let me put it another way. Whenever the angle is 30 degrees, this arc right here is going to be pi over 6 times the radius. You remember before we said that, you brought it up, you said this, if this is 30 degrees, the measure of this arc is 30 degrees, right? Was that you, Leonard? I'm sorry. Yeah? Okay. So that's something, that's the relationship between them, right? You can define an angle by measuring the arc that it creates. 30 degrees here, 30 degrees here. Well, if I have a circle of any size, right, and I put a 30-degree angle in there, if this is 1, and then this is, let's say this is 2, and then this is 3, these arc lengths right here are going to be a little bit bigger, a little bit smaller still. But if this is 30 degrees right here, then if I take this arc length and I divide it by the radius, for a 30-degree angle, this is always going to be pi over 6. I'm talking about this, and I'm just talking about turning it around. No matter how, if it's a 30-degree angle, I can take pi over 6 and multiply it by the radius. If I already have a circle, I can take the arc length. If I know what it is, I can divide it by this, and it's going to be pi over 6. If you think about what that means we could sort of set up, right, like a chart. Right? 30 degrees. That's always going to have pi over 6 when you take the arc length and divide it by the radius. And this is actually called a radian. That's what an arc length divided by the radius is. It's a measure. It's a way of measuring angles. Okay. Here, let's do this. 60 degrees. How many radians do you think that is?
5 or 12.
Okay, so 1 over 6 times 2 is 1/3. So that means 60 degrees. If I take any circle and I take the arc length that's created by a 60-degree angle and divide it by the radius, I'm going to get pi over 3 radians. Okay. Now, your book, chapter 4, right here, it basically tells the same story I just told you. Okay? Starting out here by saying magnitude of rotations are described in revolutions, degrees, and radians. What does that mean? It means how much you go around the circle. You can either say, well, okay, that's 5/36 of a full rotation, or you could say it's 50 degrees, or you could say this is so many radians. Right? 3 different ways to measure the same thing. What happens here? They give you some more examples. They talk about measuring in degrees and revolutions. Then they move on and they talk about radian measures over here, and they draw a circle sort of like I drew, where they say, hey, look, there's a ratio here. It's always going to be the same. And then before you know it, you're down here, and there's a chart, right, that has 0 degrees, how many radians is it, how many revolutions in it is it, and you should be able to fill in the chart. If I tell you 45 degrees, you should be able to tell me how many radians that is. Or if I say, I don't know, 7/12 pi, how many degrees is that?